Good afternoon and welcome to AIEC's webinar weeks. If this is your first time on the webinar today, thanks for attending. For those of you that have attended any of our previous webinars today, welcome back, glad to have you. Our next topic for our webinar is thermal drone uses and applications, presented by Fletcher Reinhardt. We're excited to have them on today with us. Again, this presentation will last about 45 minutes. We'll leave 15 minutes for question and answers at the end. We do ask that you submit all of your questions through the chat function in Zoom. Also make sure that when you send that chat message that you click the little drop-down box and send those to AIEC so that we can monitor those as the moderator, and we will present those questions to our presenter at the end. Also, please keep your microphones muted unless otherwise asked. And for those of you seeking PE credits today, if you have any questions about how to obtain those, please send your emails to badams@aiec.coop, and he'd be glad to answer any questions you might have on that. Without further ado, I'd like to welcome Kevin Reinhardt. Kevin is the inside sales engineer for FLIR, Eaton regulators and breakers, 3M Dynatel locators, and Landis & Gear meters. Kevin, I'm going to turn it over to you.
All right, well, before I introduce our speaker from FLIR, Brett, just want to let everybody know that Fletcher Reinhardt's been partnered with FLIR as a high-value partner for the last 5 to 6 years. Myself is a level 2 thermographer, and we have Jay Turner, most of you know, who is also a level 1 thermographer. FLIR has over 50 years of experience in the thermal field, and they've gotten into the drones in the last several years. I know there's been a lot of interest in flying, especially with COVID happening and social distancing requirements. So now I'd like to introduce Brett Kanda from FLIR. He is the business development manager for their SUAS product line. Brett, if you want to go ahead and take over from there.
Yeah, thanks so much, Kevin, and thank you for having me. And I'm excited to present and give everybody listening a better understanding of how thermal imaging drones are working and what the future looks like for the industry. So let's get right into it here, and we will do about 40-45 minutes of presenting, and then we'll open it up for Q&A. And we're going to start with really the overall concept of what is thermography and what does a thermal camera do. So I think it's important for everybody to understand that before we get into the actual use cases. And then we'll kind of finish off with some of the products that you would have access to in your industry. So FLIR was established and founded in 1976. We've been a publicly traded company for about 35 years at this point. We have 2 different business units. We have the government technology segment and we have the industrial technology segment. For the purposes of our conversation today, we're going to be focusing on our drone products and technologies in the industrial space. And the science and physics of what we do at FLIR is called thermography. So we'll spend the first 5 to 10 minutes here kind of deep diving some real important thermography concepts for everybody to understand, because that will help the transition into how this technology can actually be applied. So what our cameras are able to do through non-contact techniques is sense the infrared band of the electromagnetic spectrum. So to the left of the infrared band is the visible light spectrum, reds, greens, and blues, which is what our eyes see. So our cameras allow us to see in total darkness. We can see through obscurance like smoke and fog. We can measure temperature, meaning we can extract temperature values out of every pixel within the image. We can do enhanced long-range imaging, and we can accurately detect people and animals using some of our machine vision and AI cameras. So what thermography is not, it is not night vision. This is a common misconception that we hear, that thermal imaging and night vision are the same thing. Night vision actually takes small amounts of light and requires some level of light, and it amplifies it so that you are able to see an image. While thermal imaging is solely detecting emitted heat, and there is absolutely no light necessary, and our images are unaffected by light sources. So thermal imaging and night vision are very, very different. An important concept to understand for drone users is the difference between qualitative and quantitative analysis. Qualitative analysis means that you are concerned with relative temperature differences in your image. You are not necessarily extracting absolute temperature values for your images and for your data. So some great examples of qualitative use cases are firefighting, search and rescue, some roof inspections, wildlife detection, and agriculture. While on the other hand, which is probably more applicable for this group, is quantitative analysis, and industrial inspections are generally the main use case for quantitative. Now, there are going to be practices in the field that you will need to deploy to get accurate radiometry, but we do know that temperature values help with your assessing of your asset. So quantitative and qualitative is a very important concept to understand. Some of the basics of aerial thermography: radiometry, emissivity, and FLIR. Like I was just mentioning, radiometry is a set of techniques for measuring electromagnetic radiation, meaning that is, radiometry is what you'll be using if you are doing quantitative analysis. Emissivity is the ratio of energy emitted by an object compared to the energy emitted by a black body at the same temperature. In more simple terms, we'll get into that in just a minute, but everything in our environment has a different composition, a different shape, a different material, therefore it interacts with infrared radiation differently, meaning it absorbs and it reflects infrared radiation at different rates. FORD is an acronym that stands for focus, range, and distance. So if you are a drone operator in the field, these are three things that you can't change in post, meaning you have to have your focus, range, and distance at the proper levels when you're in the field capturing your data, or else whatever you're looking at in post-production might not be accurate. We do own the Infrared Training Center, which is a highly world-renowned training for infrared imaging. We offer courses around the world. Specifically, we do have UAS courses as well to help with airborne thermography. So I highly suggest, if you want to take it to the next level, like Kevin was mentioning, he's a level 2 thermographer. We have level 1, 2, and 3 training. So infraredtraining.com is the website if you want to get more information about becoming a certified thermographer.
I will interject here. We do offer classes here at Fletcher Reinhardt taught by the Infrared Training Center. So when we have one, we will let you guys know.
Absolutely. So let's dig a little bit more into the meaning of emissivity, because again, this is a very important concept to understand for quantitative use cases like industrial inspections. So as you see here, everything in our environment has a different known emissivity value. Now, as a thermographer, you'll learn the techniques that measure emissivity in the field, but most of the time people are just going to refer back to this chart. So as you can see here, we have metals versus non-metals. And the rule of thumb is that the higher the emissivity value, the higher the reliability on your temperature values. The lower the emissivity, the lower the reliability on the temperature values that you're going to have. So if you take a look here at something like a zinc polished commercial pure metal, it has an emissivity value of 0.05, meaning it's going to be very, very difficult to get accurate radiometric data. Now, on the other hand, you see a high emissivity value for something like concrete, which is a non-metal, that has an emissivity value of 0.92 to 0.97. So that is going to be a very efficient absorber and emitter of infrared radiation. And all of these values are working towards a perfect emissivity of 1. So you see that term black body. A black body is a perfect emitter and reflector of infrared radiation and has an emissivity value of 1. So that's what you work towards when you're working with different emissivity values. So highly reflective metals tend to have lower emissivities, whereas things like skin, snow, soil, wallpaper, these types of materials are going to have higher emissivity values. Kevin, feel free to jump in here because you are a level 2 thermographer, and if there's anything that I missed, please jump in and add some extra flavor.
No, how you explained it, that was definitely a good way to explain it.
Okay, great. Okay, so typically drones have just regular visible cameras on board. And when you're using just visible imagery, environmental factors don't necessarily impact your data or the quality of your image. That is very different with thermal imaging. You have to take into consideration the humidity, the time of day you're flying, wind, because believe it or not, wind at your target or wind around your sensor will actually affect the accuracy of your radiometry. air temperature and reflected apparent temperature. Because items that have lower emissivity values tend to be very reflective, that can actually change the temperature value and the way you're going to be able to read the data around the target. So reflective apparent temperature is also an important concept to understand. And there are ways to measure that in the field, but I would definitely suggest taking a thermography course to be able to do that in the field. So you'll see a concept here called spot size ratio. Spot size ratio is essentially taking the resolution of your camera, what lens you're using, and that will give you the size of the object on the ground that you're going to be able to see on the ground. And we're going to get more into this here in just a second, but do realize that where you're flying, what time of day you're flying, and the environmental conditions will impact your data and your thermal image. Okay, the next technology that I want to go over is our FLIR MSX patented technology. So some of our drone cameras are what we call EOIR, electro-optical infrared, meaning it has an infrared camera, but it also has an RGB camera. And RGB and visible are the same thing. So what this technology allows us to do is essentially blend the two images together so that you get the outline in your thermal image of the RGB camera, like in this vending machine here. Image on the left is a pure single thermal image with no MSX. And on the image on the right, we have MSX turned on. So you're blending the two images together and you are now able to see the definition and be able to read words within your thermal image. Really important for inspecting tanks or certain assets where you need to know what you're looking at. This is a patented FLIR technology that you won't be able to find in any other thermal camera. So really, really kind of cool technology. And here's a great example here of the difference between having MSX turned on and turned off. And this camera that you see on the left here is called the ZenMuse XT2. This is our most popular plug-and-play camera. It has a thermal camera as well as an RGB camera as well as MSX capabilities. So we'll get into that a little bit more here in a minute, but it's easier to really explain MSX when you can see it. So this propane tank is a great example. Okay, so now let's get a little bit more into resolution. So thermal cameras come in different resolutions. For any of you that are drone operators, you might be flying the Parrot Anafi Thermal or the DJI Mavic Enterprise Dual. That camera has our Lepton core, which has a resolution of 160 by 120. It's a microprocessor. It's very, very small, but still gives you a thermal image. It just has lower resolution than some of our other options. Our most popular drone cameras like the XT2 and the Duo Pro R come in two different resolution options, a 336 by 256 option and a 640 by 512. 640 by 512 is the highest resolution that we currently offer for drone operators, and we always suggest that drone operators use a 640 resolution. But you're also going to have different lens options, 9, 13, 19, and 25. What we tend to see in the market is that industrial inspection users like yourselves tend to opt for the 19 and the 25 millimeter lens, so you have a little bit narrower field of view, as opposed to a really wide field of view, which is great for search and rescue and some different public safety operations. So high resolution and a 19 or 25 millimeter lens is definitely the best option for utilities and inspection use cases. So now we're going to go into a visual representation of the difference between our different resolution cameras. So image on the left is our Lepton, which I mentioned earlier, has a resolution of 160 by 120. Image on the right is taken with our high resolution 640 by 512 ZenMuse XT2. And what you're looking at here is a 12-inch in diameter pizza pan that's been heated up to about 350 degrees, and it's sitting on concrete. So this first image was taken at 25 feet. You can already see the difference in clarity between the two images. Let's go to 50 feet. You're continuing to lose resolution on the left, while the image quality on the right is maintaining and still looking really nice. Now, when you get up to 100 feet, almost impossible to tell what that image is on the left, while we can still absolutely see that pizza pan on the right. So the point of this demonstration is to say that not all thermal cameras are made the same. So you have to have a good understanding of what capabilities each resolution camera has. And again, for industrial inspections, we always suggest that you use a 640 by 512 high resolution camera. So yeah, hopefully that helps kind of depict visually the difference between the resolution cameras. And this is just a graphical representation of resolution capabilities. X-axis, you're going to have your flight altitude in AGL, so above ground level. Y-axis is going to be the size of each pixel of the target on the ground. So the red dots here are a high resolution camera. The higher you fly, the smaller the object on the ground can be for you to see it. Whereas the blue dots, the higher you fly, the bigger the object on the ground is going to have to be for you to see it. So if you're using a lepton-based camera, we suggest that you fly below 80 or 90 feet AGL to see something the size of a human. Next, we're going to go into color palettes. So because what our cameras are sensing are not visible to the naked eye, we had to create artificial backgrounds so we could actually see what the image is capturing. So that's what we developed color palettes. There's about 15 different color palettes available for drone users, but what you're seeing in this image is a visual representation of what the camera is capturing. The brighter the colors, so you see reds and yellows and oranges, those are going to be the hotter items within the frame. The darker colors represent the colder items in the frame. So rainbow and iron bow are the two that we suggest for industrial inspections because you have a wider range of temperature values represented within your image. Here's another example of our iron bow color palette. So again, you can see his face, you can see his hands, his legs, his body, the hottest thing within this frame. And obviously he's standing in a forest or something like that. But we also have color palettes that are white hot and black hot, meaning everything in the image is either white or black. And for like a black hot color palette, for example, the hottest objects in that frame are going to be black, while the colder things in the frame are going to be white, and vice versa for a white hot color palette. So now let's get a little bit more into some of the use cases that we're seeing traction in both the utility and the energy space. So we're seeing a lot of activity in solar inspections. And I like to talk about what's currently being done for testing the output and productivity of solar today. And so what people are doing now is taking a highly skilled electrician, going out with a manual electrical testing device, shutting down the array, plugging in that device, downloading the data, and then repeat for every single panel within that field. Obviously, very time consuming. The data is not going to be turned around quickly. It will take weeks to get that information back, which is going to decrease the volume and the amount of times that you're going to conduct these types of inspections, which means downtime equals no production and loss of money. So that's what's currently being done today. And using drone-based thermal imaging, you are now able to take an affordable system, fly over a very, very large area, keep the panels running so you can get down to cell level defects with the thermal imaging camera. You're going to be able to see if a panel is out. You're going to be able to see if it's overheating. You're going to be able to see soiling problems, shading problems. And this is something where you're going to be able to get your data either in real time or in worst case scenario, a report by the end of the day, maybe the next morning. So you're saving time, you're saving money, and it is a much more efficient and effective way to go ahead and inspect solar panels. However, if you go back to what I was talking about, when it comes to emissivity, solar panels tend to be very, very reflective and have a low emissivity value. So you have to make sure that you are setting proper emissivity settings, using a dual EO-IR payload like I mentioned so that you can verify any anomaly that you see in the field. You have to consider environmental factors. And the best time of day to fly a solar field is going to be at 12 noon, because at that point, the solar panels have been able to get their irradiance up to a level where you're going to be able to see actual problems. So here's a quick video of a good example of flying over a solar field. Image on the left is going to be your RGB imagery. Image on the right is going to be your solar image. So obviously you see something wrong with two panels here that you can't necessarily see as well in the RGB image, but with the thermal, it's clear as day. So a really good example of what drones are able to do in this with this particular use case. Okay, next, let's go over substation inspection. Traditionally today, you're going to have a thermographer going around this asset with a handheld camera inspecting it, but that leaves the top of the asset and some of the harder to reach places. It's not as easy to get to those locations. So using a drone, you are now able to create a digital twin of this asset and in real time know exactly what's happening with that substation. If something is malfunctioning or overheating, it's going to be very apparent. If something has already been blown out and is not creating a temperature signature at all, you will also know that there's a problem. But for most drone users, it's really important to understand that what we're doing and the value that we're bringing is creating a real-time digital asset, digital representation and digital duplicate of your asset, so that you can be able to do trend analysis and understand over time what's happening with that substation. And that applies for every use case, but substation specifically. You are now able to inspect this very quickly. Larger scale substations, it's going to be easier using a drone as well. And especially with a thermal imaging camera for the reasons that I just mentioned. You're going to be able to have an entire 360-degree view of your asset and its thermal signature. So power line inspection is another use case where we're seeing a lot of traction for thermal imaging drones, because traditionally today, as you guys know, you have to send a team up, put them in harm's way while they're inspecting the asset. And it does take time and energy, and therefore you are not inspecting your assets as frequently as you could. Using a drone, you're again able to create an entire digital duplicate of your asset while being able to see anything that's happening, any type of anomaly that's happening with that asset from a thermal perspective. So, you can use video, you can use still images, you can create 3D maps. There are a number of different outputs and deliverables that are going to be valuable to the end user. But again, drones are saving time, money, and giving you more data and more insights into your assets than you've ever been able to see before. So a new phenomenon in the drone industry is creating thermal maps. Like I said, you are now able to take a drone, have it fly a predetermined pattern, taking images at different intervals, and going into different pieces of software, stitching that together and creating what we call 3D ortho mosaics, so that you can see your entire asset within a 3D ortho. Now, because this is such a new science, there are a couple best practices that I want to go over if you do want to go down this path. And most importantly is flying low and slow. We do not want to fly high and fast because you will get motion blur. So make sure that you're flying nice and low and slow with a high level of overlap and side lap, minimum of 80-80. Time of day depends really on what your use case is. For solar panel inspection, you're going to want to fly at high noon. However, for roof inspection, for example, you're going to want to fly 30 minutes after sunset. So depending on your use case, that will determine when you want to fly. But when it comes to thermal mapping, you also need to understand that you have to do qualitative analysis only from a 3D ortho mosaic. You do not want to do anything quantitative for these exact reasons here. During the image stitching process, the current software on the market are not taking into consideration emissivity, reflective apparent temperature, distance, humidity, and spot size ratio. So without those pieces of the formula taken into consideration, it's going to be impossible to get accurate radiometry from a 3D model. So just stick to qualitative relative temperature differences if you do want to go down this path. Okay, so now some of the products that you have access to be able to do this. The FLIR View Pro is a single thermal imager that's drone agnostic, so it can be adapted onto a number of different drones. Comes in both a 336 and a 640 resolution option. It also comes in a radiometric and a non-radiometric version. So when you see our cameras have an R at the end, that means that the camera is able to output radiometric data, meaning you have temperature values within every single pixel. If it doesn't have an R, that doesn't mean that it's not capturing radiometric data. It's just taking the average of multiple pixels around your main target, so it's not going to be as accurate. So the View Pro comes in a radiometric and a non-radiometric option. The Duo Pro R is our drone agnostic payload that has EO/IR capabilities. Again, 336 by 256 and 640 resolutions are available. Because this camera is an EO/IR payload, it does have MSX capabilities. It also has built-in an IMU and GPS for georeferencing images if you do have your surveyor using this technology. So if you are flying anything other than a DJI, this is the thermal camera that you would use. And as you see here, it does take a third-party gimbal to integrate onto your airframe. Okay, for most of the market that are flying DJI systems, these are the two payloads that we developed together with DJI. The ZenMuse XT at this point is a bit out of date. However, the ZenMuse XT2 is still available on the market. And this has been the most popular product that we've seen in the drone space. And it truly was revolutionary in how easy it is to use along with the software capabilities that we worked on together with DJI. So this is going to give you very specific AI features. For example, the XT2 allows you to do a capability called heat track. So the hottest object in the frame, you're going to have a box around your image, and the gimbal and the camera are going to point directly at the hottest item in the frame at all times. So a really great technology to be able to spot certain anomalies in your asset. So that's just one awesome feature with the XT2. But this camera is compatible with the entire DJI Matrice line. So the 200, the 210, as well as the new DJI M300, as well as the 600. So our newest payload here that we just released and are getting ready to ship is called the FLIR TZ20. This is a one-of-a-kind payload because this is the only drone payload in the world that allows you to do a thermal zoom. So inside of this camera, you have a wide field of view and a narrow field of view boson thermal core that gives you an incredible wide situational awareness and allows you to zoom up to 20 times. The 2x and the 4x zoom are optical zoom, and the 10x and the 20x levels are a digital zoom. So it does maintain image quality. We did a test not too long ago in Santa Barbara, California, and the pilot was standing on the beach. The drone was flying at 400 feet AGL, but the slant range was about 700 feet away. And from the wide field of view of the camera, you could see the entire coast, probably 6 miles of California coast, and see everything with in that entire frame. And then when we went to a 20 times zoom, you were able to see the pilot's elbow waving on the beach. So the zoom capabilities are pretty impressive on this camera, and we're looking forward to getting it into the market here very soon. And when we built this camera, we were really focused on public safety. However, it is a great camera for inspection as well, because you're able to have a wide field of view, so you get a entire overview of your asset, and you're also going to be able to zoom in and verify any type of anomaly that you might see. And this is a DJI PSDK payload, meaning it is a plug-and-play solution for the DJI M200 210 version 2, as well as the new M300. So again, another camera compatible with DJI systems, which are the majority of the airframes out in the marketplace today. Now, a very flexible camera that we have is called the Hadron. We built this camera for the US Army as part of a short-range reconnaissance program. This is a really flexible camera and doesn't necessarily need to be put on a drone. It can be put in different ground-based robotics. It can be used as a fixed sensor, but it is 42 grams and will fit in the palm of your hand. So a really kind of cool, flexible EO/IR payload that can be versatile in its use case. So definitely something to consider as we move forward here. There's been a few drones that have this camera integrated. Teal Drones and Vantage Robotics are two systems that have taken the Hadron and integrated them for the Army, but they've also been allowed to commercialize the system out into the industrial space. So a very impressive system that is an incredibly small form factor and one that we're pretty proud of. So that was a ton of information in a short amount of time. And if you want to learn some more about everything that I've been reviewing today, please check out the FLIR Delta page, the Drone Education Lab for Thermal Applications. There are podcasts, webinars, how-to videos, best practices, you name it, you're going to be able to learn everything drone-based thermal imaging within that website. As I mentioned earlier, you can also take the next step and go to an infrared training center class where you can become level 1, 2, and 3 certified. There are also UAS specific courses within ITC. And then our YouTube page has a lot of great information as well. So I suggest everybody take a look at that. And I guess with that, we can kind of go directly into some questions here. And I assume the questions are in the chat box.
Brett, at this time, we don't have any questions coming in yet. We'll give it a couple seconds here and see if we can get any questions. As just a reminder, please submit those questions through the chat function.
Yes, I'd like to add, Fletcher Reinhardt does have the XT2 on a DJI M210 frame for anybody that would like to see it in action. We can schedule something to come out and fly, and as soon as this quarantine period ends, we will be hosting ITC classes here back at our facility for those interested.
That's a good point. And I think it's also important to talk about, how many companies are actually doing this within your industry. And we've seen companies like Southern Company and some of the Berkshire Hathaway companies deploy this type of technology at scale, meaning there are, 50 to 100 drones and 50 to 100 pilots within those companies that are out there every day conducting flight operations. And there have been some studies about the ROI of implementing this type of technology, and it's pretty clear that this is going to save a significant amount of money and give you more insight into the production of your asset.
Thank you for that, Brett. We still don't have any questions coming in. At this time, I think we can probably go ahead and wrap it up, maybe give you a little bit of your day back. I want to give a quick thank you to Fletcher Reinhardt, Brett, and Kevin, both for presenting today. It's been very informative. Real quick, Brett or Kevin, if anyone's got any questions that they'd like to shoot you later on, how can they contact you?
Yeah, go ahead, Kevin.
So if you email me or your outside sales guy, for those of you in Illinois, they'll get me the questions and I can relay them to Brett if I can't answer them. Looks like Brett just put his email out there in the chat.
Sure.
Everybody should have my email address.
Yeah, if you ever have any product questions, please go directly to Kevin. And any, honestly, thermography questions, Kevin's going to be able to answer them probably better than I would anyways. So if there's anything that I can do to help, please feel free to reach out. But Kevin is an amazing resource for all things drone-based thermal imaging related.
Very good. Well, thank you for that. And you can always reach out to Ashley and she can get you in contact with them as well. Thanks again for presenting. We have one more webinar up this afternoon. We're going to have a legal and government relations update from Craig Sondroth and Nick Reitz. So we look forward to having you back again for that if you so choose. And with that, I think we will go ahead and conclude this meeting. Thank you very much.
Thanks so much.